Okay, so here's a brief video on force and momentum, the relationship between the two. So there are your note headings. Right, so a brief reminder what momentum is. It's simply the mass of an object multiplied by its velocity. So faster something's going, the more momentum it's got. The heavier something is, the more momentum it's got. And it has the units, kilogram meters per second. And if you like your equation triangles, you've got that equation triangle there. Okay, so we can talk about Newton's second law, which, as we saw in previous lesson, Newton's second law was basically F equals ma. So if we have an overall force acting on an object, it accelerates. But we can also talk about Newton's second law in terms of momentum. So as it says there, force is directly proportional to the rate of momentum. Okay, so what that means is when we apply force to something, because it accelerates, it gets faster, therefore its momentum increases. So when you apply an overall force to an object, its momentum changes. So if you apply a force to slow something down, a decelerating force, that object slows down and it loses momentum. If you apply a force and something speeds up, it accelerates, it increases momentum. So we can talk about, because force is directly proportional to the rate of change in momentum, we get this equation here: force equals change in momentum over time. Or in terms of symbols, we've got force F equals mv, v being the final velocity, minus mu, u being the initial velocity, and m obviously being the mass of the object, and time being the time that it takes, the time you apply that force for. Okay, so that's the relationship. The bigger the force, the bigger the rate of change in momentum. So things that have big momentum are things that are either very heavy or things that are very fast, or a combination of the two. So what this relation between force and momentum tells us, that all of these things which have big momentum, they will require a very big force to stop them, because the change in momentum, if you've got this bullet, for instance, bullet there's got high momentum. If you want to stop it, it's got big momentum, and then it has zero momentum when it's stopped. So by changing its momentum, you have to have applied a force to it. And the same goes for all these other objects as well. So they all have a large momentum. So because when you bring it to a stop, the momentum drops down to zero, that means you need a big force to do it. Okay, so here's a couple of examples. So we've got, it says during a crash test, a dummy's head hits the windscreen of a car. It's going at 30 meters per second. So that's the initial velocity. That's what it's already traveling at. So that's u. The dummy's head comes to rest rest. That's v. Basically, that's the final velocity, 0. And then we've got in a time of 0.01 seconds. So that's t. And then we've got the dummy's head has a mass of 2 kilograms, and it says what is the force. So force is change in momentum, so that's mv minus mu over time. So substituting in, we've got 2 times v, well v was 0, minus, we could probably put that in brackets, 2 times u, the initial velocity, which is 30, divided by 0.01. Okay, so what we get is 2 times 30 is 60, divided by 0.01 gives us a force of 6,000 newtons. Okay, so a very large force. Okay, so your head hits a windscreen when you're going at 30 meters per second, which is pretty fast. You experience an extremely large force. Okay, so another example here, we've got a gymnast falls off a pommel horse. They hit the hard floor. They come to a stop in 0.01 seconds. If they land on a crash mat, they come to a stop in 0.1 seconds. How many times harder is the floor landing than the crash landing? So what we don't have a momentum here. We've just got a time. Now the momentum will be the same, or the momentum change will be the same in both instances, because if we've got our gymnast here, they've got a mass of whatever, and when they start to fall, they've got an initial speed of whatever. So they've got a momentum of whatever. When they hit the ground, that momentum will be 0.
So the change in momentum is whatever the momentum was before, because you're doing initial momentum minus, so new momentum minus initial momentum, so 0 minus initial momentum, it's basically the initial momentum. So if we did the momentum, or change in momentum, delta mv, so delta is changing, m, that's meant to be a v, times v is change in momentum, over time, well in the first case, we're dividing by 0.01. In the second case, we've still got the same change in momentum, delta mv, but we're now dividing it by 0.1. Now, divided by 0.1 is the same as multiplying by 10. Divided by 0.01 is the same as multiplying by 100. So that force will be 10 times greater than that force. So when you hit the ground without the crash mat, the force exerted on you is 10 times bigger than the force exerted on you when you hit the crash mat. Hence, we have crash mats at gymnastics. So in a nutshell, basically what we know now about momentum is, if you want to stop something quickly, you've got to apply a big force to that object, because the rate of change in momentum, in other words, the time it takes, how quickly the momentum changes, that's very high. If you want to stop something slowly, it requires a smaller force because the rate of change of momentum is low. So you're changing that momentum over a longer period of time. So when you stop suddenly, you require a big force, so it puts more stress on the brakes because your momentum changes quickly. Whereas if you gently come to a stop, the force required is less, so the brakes are under less stress. Okay, so that's the end of that.